All right, in this next section, we're talking about combining two random events, or more than two, it doesn't have to be two, but two or more random events together by either adding or subtracting two or more random events together. So that's not the same thing as what we were just doing, where we had run one random event plus a constant. Now we have one random event plus another random event, or minus another random event. So in general, the mean of the sum of two random variables is the sum of their means. That might sound a little funny, but if you kind of think about what it's saying, the mean of the sum of two random variables is the sum of their means. This is true for the difference as well. The mean of the difference of two random variables is the difference of their means. So I can write this out in like a formula. The mean of the sum or difference of two random variables, and I'll use x and y, just our two typical variables, is just the mean of the first one plus or minus the mean of the second one. So that's pretty basic and pretty simple. In fact, if I probably would have asked you to do a problem using this without teaching you, it's naturally what you probably would just do on your own. It's pretty intuitive. Now, where this gets a little bit more interesting is when we talk about their standard deviations. So first of all, we have a requirement. In order to do anything with their standard deviations, the two events must be independent. So knowing something about the first event or knowing the first event has occurred has no effect on the second event. That's important. And the standard deviation of their sum or difference is always the sum, excuse me, I wrote the wrong word here, the variance of their sum or difference is always the sum of their individual variances. So the variance of x plus or minus y is always the variance of x plus the variance of y. Notice I did not include the minus sign here, okay? Because we never subtract variances. Remember, variation is how off data can be. If we are combining two random events, so we're already not 100% sure what's going to happen on these individuals, when I combine two unsure things together, I should be more unsure of the outcome, not less. So we never subtract variances or standard deviations. We add variance. Now this is called the Pythagorean theorem of statistics. That is not an official terminology. But that's to help you kind of remember this. This is not on your formula sheet. For example, let's do standard deviation instead of variance. So I'm going to come over here and write it on the side. The standard deviation of x plus or minus y would be the standard deviation of x, but squared, because we add the variances. So I got to square that, plus the standard deviation squared of y. Now this is the variance of x, this is the variance of y. When you add those together, you get the variance. But I want the standard deviation, so I got to take the square root. Now if you look closely at this, this looks like a Pythagorean theorem. Square root of x a squared plus b squared. And so you hear that this rule is sometimes called you'll hear me refer to it as the Pythagorean theorem of statistics. It's kind of like if you're trying to find the hypotenuse of the triangle, you don't just add a and b. You add a squared, b squared, and then take the square root to get the hypotenuse. If you want the standard deviation of the sum of two random variables, you don't just add their standard deviations. You have to square each one, then add them and take the square root, just like in a right triangle. You'll hear me say this a lot. It's kind of gross, but it kind of helps you. You can't combine STDs, like sexually transmitted diseases, Kind of gross, but it really means standard deviations. You can't combine STDs, as in you can't add or subtract them ever. If you want to add variances, no problem, but you can't add the standard deviations. You must add the variances. All right, so if two couples go to a restaurant on Valentine's Day and they decide to get separate checks and then pool their discounts afterwards, how will this affect the mean and the standard deviation? So what's happening here is, instead of like in the previous problem where they dine on one check and double their discount, this time they're going to pool their discount. So one couple is going to get a discount and then the other couple is going to get a discount. Notice I'm writing D1 plus D2. Not D plus D. I'll talk about that in the video in just a minute. But that's because they might not get the same discounts. This couple might get the $20, this couple might get a $0. So they're not necessarily the same outcome. So I don't want to use the exact same letter. So the mean is just going to be this discount of one, the mean of the first one plus the mean of the second one. So that was your 583 plus your 583. And we add those together and we get our 1166. So notice the mean did not change. Whether they got the double discount or they pooled their discount, the mean is the same. Now, the standard deviation is where we're going to see a difference. Remember, we add variances, not standard deviation. So if I want to do the standard deviation, I've got to take the variance, which was 1124 is not correct. Sorry, it's 862. Let's fix that. The standard deviation of the Lucky Lovers discount was 862. I have to square that for a variance, add it to the second discount, which still was 862 standard deviation. It's the same event. Square that. Then those two numbers added together would be my variance. So this would be the variance of the sum of the two events. Remember the variance I think was 71 something, so you can see that that would add up to about this number. And then take the square root of that to get the variance of pooling the discount. So if I compare that to the previous problem, does it matter if they double it or pool it together? And the difference is in the variance. Doubling it, the variance or the standard deviation was 1724. Pooling it, the standard deviation was 1219. Which one is better or worse? That's kind of, you could think about that and come up with your own opinion to that. But basically, does it matter if they pay separately or together? The average is the same. But dining together, that's the other one, has more variability in the outcomes. So you might be thinking, well, you have a higher chance of getting a bigger discount, which is true, but you also have a higher chance of getting a smaller discount. This discount is going to be a little bit more stable around the middle of 1166. So you don't have the ability to get as high as the other one, but you also, it's a little safer. You don't have the ability to get as low either. See if you can do this next problem. I'll come back on and do this problem as well, but maybe pause the video and see if you can do that one on your own.